So previously I did a video on mesh analysis, but this is going to be a super mesh, which means it has this current source, which is going to be in between two of your meshes. And of course, it's going to make things just a little bit more difficult, but we're going to break it up one step at a time and go very slowly. If you get anything out of this, subscribe, like, comment what was good, comment what was bad. It'll be super appreciated, and it will help this channel grow more than I ever would have thought that those little things would help. So first, let's take a look at this. So we're going to use mesh analysis with a super mesh, which is going to be this big chunk right here. So like normal, let's define three mesh currents. Number one, so we have I1. Let's call this top one I2. And we're going to call this bottom one I3. So far, no different. Just like when we did super node, we had to make a constraint equation. So we're going to do the same thing with the super mesh. So before we go no further, let's define the super mesh. So we see in between I2 and I3, we have this 4 milliamp source. Well, we can't really have that. That's going to throw everything off because you have I2 going this way, which that would just be negative 4 amps. I3 is going this way, which would be positive 4 milliamps. Now all of a sudden that nets to 0. It makes no sense. So effectively, we're going to pretend it's not there. And let's go ahead and highlight what is the super mesh. The super mesh is going to be this ring. So we'll follow it along with this green highlighter. So that's your super mesh. Let me make this a little bit more obvious. There we go. So now you're going to treat this as just one big mesh, in other words, a super mesh. And we're going to have a constraint equation. We know we have to have 4 milliamps going in this direction. That's non-negotiable. And we have I2 going that way, I3 going that way. And remember, I2 is going this way, and I3 is going this way, just because that's the directions that we chose to begin with. Always keep these mesh circles the exact same every time. They all have to be clockwise or they all have to be counterclockwise. You get to pick, but make sure they're the same, keep them consistent. So now we're going to make a constraint equation. We know that 4 milliamps is going to equal I3 minus I2. Now let's solve that to where we have I3 equals 4 milliamps plus I2. All I did was just add that I2 over. So this is one of our equations, and this is going to be super important. We're going to use that in just a few minutes. Another thing that we already have, look at I1, and look what's here. Now I1's not sharing anything, and this isn't a branch all by itself. So we have this 2 milliamp source just being gifted to I1. So we also know I1 equals 2 milliamps. That's going to help us out later. Now this is where things are going to start to get a little bit messy. We're going to make a KVL equation around this entire super mesh. And all this is with the goal, if you can see here, we have IO. That's the current we're looking for. This is what we're trying to get to. What is IO? We're going to worry about that at the very end. Let's go ahead and define everything else first. So now for our KVL around this giant supernode. This is going to get a little bit hairy, so we're going to go very slow, one step at a time. So every KVL and KCL equation begins with the same thing, 0 equals. Let's start here, following the I2 around. So what we're going to hit first is negative 6 volts. Then we come to this 1 k ohm resistor, and before we go any further, let's go ahead and mark our resistors so we know their polarity. Let's just go ahead and say plus minus, since we have this plus here, we're going to be going this direction. Ground is probably down here. IO is coming down here. 2 milliamps going up there. So we're going to say this is plus, this is minus. We're going to say that's plus, that's minus. Because we have I1 going this way, we're going to do plus and minus on that 1 k ohm resistor right there. Let me write on the other side. Let me write it there just in case the green highlighter kind of interferes with what you can see. All right, so we have 0 equals negative 6 volts from there. Let's continue. Now we hit our positive 1 k ohm resistor, and it's only using I2. Next, we're going to follow the super mesh. Remember, we X this out. Pretend this shared source here, it does not exist. Don't even worry about it. So we're going to hit this positive 2 k ohm resistor, and it's holding on to I3. This is all I3's branch right here. All right, we're going to keep following the supernode. Now we're going to hit the negative side of this 2 k ohm resistor, and it's shared. It has current I1 coming down. It's got current I3 going up. So here's I1. There's I3. We're going to use whichever one hits the positive side. We're going to put that one first. then it'll be minus the current hitting the negative side. So let's write negative 2k ohm times I1 minus I3. Okay, let's keep going around the loop. So next on the supermesh is this 1k ohm resistor. And because we're going this way around the supermesh with I2 here, we're going to hit this negative sign on the 1k ohm resistor. So let's go ahead and write negative 1k ohm, and it's going to be multiplied by I1 is hitting the positive side, I2 is hitting the negative side. So I1 minus I2. And this is your KVL equation. It's a beast. Take it one step at a time, go slow. A lot of people mess up, usually with the algebra through this gigantic mess. So just go slow and be careful. So first things first, we have I1 equals 2 milliamps. So I'm going to go through and put 2 milliamps wherever the I1s are. Otherwise, I'm going to keep it the exact same. Okay, so the only thing different now is wherever there was an I1, I put 2 milliamps since that was given to us. Next, we're going to start simplifying by distributing everything through. And wherever we have kiloohm hitting milliamps, such as negative 2 k ohm multiplying by 2 milliamps, that's going to turn into volts. So 2 k ohm times 2 milliamps, as an example, will be negative 4 volts. So go through, do your distributions, but don't start simplifying just yet. Okay, so now we should have negative 6 volts plus 1 k ohm I2 plus 2 k ohm I3 minus 4 volts plus 2 k ohm I3 minus 2 volts plus 1 k ohm I2. Again, you might find this unnecessary, but we're just going to do one small step at a time. I'm going to get my voltages over here, so we're going to plus 6 volts, plus 4 volts, plus 2 volts for a total of 12 volts, and I'm going to combine the I2s and the I3s. Now we should have this much smaller, nicer equation. 12 volts equals 2 k ohm I2 plus 4 k ohm I3. So what do we do from here? Because we have this one equation with these two variables, but here's our constraint. I3 equals 4 milliamps plus I2. So let's take that and plug it in right here. Now 12 volts equals 2 k ohm I2 plus 4 k ohm times 4 milliamps plus I2. All right, let's distribute this 4 k ohm. 12 volts equals 2 k ohm I2 plus 16 volts plus 4 k ohm I2. Now we're just going to subtract the 16 volt over, add the 2 k ohm I2 and the 4 k ohm I2 up. Negative 4 volts equals 6 k ohm I2. Divide everybody by 6 k ohm. So we go from this to I2 equals negative 0.67 milliamps. But what we really want to know is what is I0, all right? And for the sake of some space, I'm going to write that right up here. So what is I0? What does I0 equal, other than interosseous if you're in the medical world? I0 is going to be I1 coming down, I3 going up. So it's going to be I1 minus I3. We already know what I1 is. It's 2 milliamps. So now that we have I2 equals negative 0.67 milliamps, let's look here at I3 equals 4 milliamps plus I2. So now we know I3 is 4 milliamps plus negative 0.67. That here down at the bottom. And now we have I3 equals 3.33 milliamps. So we're going to use that for the equation that we really want, which is the equation for I0. The whole goal is to find I0. So I0 is going to equal I1 coming down, because I1 is coming down this way, following the direction of I0, which was pre-indicated, and I3 is going up against it. So that means you're going to have I1 minus I3. I1 was given, that's 2 milliamps. I3 we just found out is 3.33 milliamps. So let's fill this in. So 2 milliamps minus 3.33 is, of course, negative 1.33 milliamps. Hopefully that helps out with Supermesh. Thanks for sticking around.